what is up guys? This is Ivan from Brainy-Bits.com, and in the tutorial today what we're going to do, we're going to build a little system here that is going to enable us to control a stepper motor by entering a number on a keypad, and that number is going to be in millimeters for our project today. And what's going to happen is going to make the stepper move that distance and display the result on an LCD. So let me switch the camera so we can look at the components. So let's say we start here at the motor. So we have an EMA 17 motor, and it's got a 40 teeth pulley on it. And let me zoom in a little bit so you can see it a little bit better. So there you go. That's the motor with the pulley. And then we have our belt that loops around. And we have our little belt clip here that is aligned with 0, as you can see here. So when I enter a number, this pulley is going to move, and we're going to be able to see if it's accurate. And at the end here we have a little idler pulley, so the pulley goes all the way around and comes back. Now if we move up to the project here, for our tutorial today we're using a Mega because we needed more pins. It could be done with an Uno. It's because I'm connecting the keypad directly without using any resistors, so this keypad, actually let me move up a little bit, here we go. This keypad is a 4x4 matrix, so it's got 16 buttons. But in today's tutorial, we're only using this part here, so we're using 12 buttons. But you could add some stuff to the code to actually use the ABCD button. Whoops, sorry, couldn't see that. The ABCD buttons here, if you wanted to. So we'll see that when we get into the code. And then next to it, we have a little easy driver stepper motor. We used these before in other tutorials. And we actually used the keypad too in another tutorial. And the Nokia LCD that we see here, that's going to display the position that we want to move to when we enter a number on the keypad, and it's going to actually display also the current position of the motor. We did a tutorial on this too, so I invite you guys to go check out our video library, and you'll see separate tutorials for each one of these parts, actually, the keypad, the easy driver, and the Nokia. And basically what I did, I took the code that I wrote for these and merged it together and made some modification to actually create this tutorial that we're going to do today. So that's the setup we have, and now we're going to go and look at the code that makes it all work. And once we've done that, we'll come back and test this little setup right here. So let's go check that out. Alright, so here we are in the code that we're going to use for this tutorial today. And throughout this explanation of the code, I'm going to refer you guys to other videos that we did that actually is using the same exact, pretty much the same exact code. I'm going to do that because I don't want to repeat everything that I said in other videos, or else this video is going to run too long. So if you guys are interested to get more information about that piece of code, I will refer you to another video that we did before. So let's go ahead. So we're including the Excel stepper library. This is a great library if you want to use stepper motors. It's got a lot of options. We're actually using two today. We're using the max speed and the acceleration settings to set the maximum speed that we want our stepper to move, and the acceleration at which it will ramp up to that speed. So we'll see that a little later. And then we're including the Keypad library and the UHG lib library for the Nokia LCD. Now these two here, like I was saying, you can refer to the videos. You should see them appearing on the top there. There's one that we use that Keypad library, and the other one for the Nokia. You'll get more explanation on these two here. Here we have variables to hold, enter number on keypad. Again, we did a 3-part video building a Dart scoreboard machine. And the code that you're going to see here is basically the same code that we use for that. So I will refer you to that video if you want more explanation of how this works. Quickly though, first number, second number, third number, basically we'll hold every number that we enter on the keypad in sequence. So when we press 1, and that's the first number, it will be entered in this variable, second number, third number. So basically we have 3 numbers that we can enter. Our tutorial is in millimeters. So basically that gives us 999, which is about a meter, since 100 centimeters is a meter. Well, it should be 1,000 millimeters is a meter, so that would be good up to a meter. If you want longer than that, you would have to add a 4th number here and modify some of the code. And then we have variable to hold distance and current position, because We're going to save the current position so we can display that on the Nokia LCD. So key full number here, that's going to be used to store the number. Because when we enter the numbers 1, 2, and 3 here, they're separate numbers. So we're going to do a little calculation to make it a full number so it becomes 123 and put it in this variable here. So we set it at 0 at the beginning. Current position, it's a string. And the reason for that is that the Nokia LCD with the UHG lib can only display characters. It can't display actual integer or numbers. So we're going to take the current position, which will be an integer, and transform it into a string so we can display it easily on the Nokia. And then we have the keypad setup, so you can check that out in the other video. This is exactly the same. The UHG setup, again, we're defining a backlight pin which will control the LEDs on the Nokia LCD, and then which pins are connected to which pin on the Nokia right here. And here's the Excel steppers setup. So we're calling the library, we're creating an instance of it, and the one here refers to any driver, motor driver that you're going to use that has a direction and a step pin. You will put 1. There's three more options here. And also, I'd like to let you guys know that you can go check out on our website the tutorial page for this tutorial. That will be available probably the end of the week or beginning of next week, and you'll get links and more information on these libraries that we're using here. So basically, for our purposes, 1 is good for the Easy Driver, and A0 and A1 are connected to the step and direction pin of the Easy Driver. And then we get to our main setup, so we're lighting up the LEDs. 0 is the brightest, 250 is like off, so you could set a number here if it's too bright or not bright enough. And here are the two settings of the XL stepper that we're using, the max speed and the acceleration. Don't put these too high or else your stepper will miss steps, so it won't be accurate. So you'll have to play around with your setup with these two numbers. Now, then we draw the starting screen on the Nokia LCD. Again, check out the video that we did just on this Nokia LCD, but very quickly, when you draw a screen on the Nokia, it's a whole screen. So basically, if you want to add something to that screen, you will have to redraw the whole screen again. You can't just go ahead and say, okay, I want to add just millimeters, because that will not work. It's a whole page at a time, and you'll see how we do that later on. And then we have our main loop. So the main loop, the switch case for the keypad, we saw that in the other video. You can check that out if you want. So basically we're calling, depending on the number that we're entering on the keypad, we're calling the function and passing the value that the key corresponds to. And if we press the star, that's delete numbers, so that acts like a backspace. We'll see that when you do the testing. And calculate distance, that's like the enter key, so meaning move the motor. So here we get into our functions at the end. All the functions I always put at the end here, as you can see. So we're going to start with the first one. There it is. Check number. Again, this comes from the dartboard video, so you could check more information on that. But one thing that is different here is that the string display value, we're calling that, is equal to the string of first number, because first number is an integer. So we need to transform that integer to a string for display on the Nokia LCD. So once that is done, then display value here contains the value of first number, which was an integer but has characters. And then we say draw Nokia screen and pass that display value. Now we're going to jump right away to draw Nokia screen a little bit more. I think it's near the end. Yeah, there it is. And so we say, okay, the display value, it's a string, and we're going to put in the value in the variable y. And then we just redraw the whole page. Like I said, you need to redraw the whole page. So it will enter, it will redraw the whole screen, but it will put the entered number on the Nokia LCD, and we'll see that. So let's go back up. So the check number, that's what it does for each number that we enter. Delete number, basically what it does is that it enables us to go do a backspace. And again, we did see that in Dart scoreboard videos. Check that out. And then calculate distance. Basically, when we press enter, it's going to check if the third number is equal to 99, second 99, and first number is not equal to 99. That means we only entered one number. So the key full number that we saw at the top will be equal to first number only, because 1 is equal to 1. And then we say move stepper to that key full number. So we're going to go to move stepper here. Alright, so the move stepper, I'm going to try to explain it as much as I possibly can, as simple as I can. There's a calculation that we do here. Now, if you look on the screen, the GT2 belt that we're using is a 2 millimeter pitch. So that means that between teeth, there's 2 millimeter distance. Now we're using a 40 teeth pulley. So that means then one revolution of that pulley, there's 40 teeth that went by. And if each teeth, the distance, is 2 millimeter, then a full revolution would do 80 millimeter. Our belt would move 80 millimeters. Now, okay, so we got that. We got the 80 millimeter per revolution. Now we know that our stepper is equal to, one revolution of our stepper is equal to 200 full steps. And you can find that out by checking the specifications of your motors. But for us, 200 full steps, then the shaft will have moved, rotated one full revolution. Now the easy driver that we're using, by default, it defaults to 1/8 of a step. So basically what that means that it takes 8 steps to do one step with the easy driver. You can modify that by putting the MS1 and MS2 pin high or low, but if you don't connect anything, by default it will do 1/8 of a step. So if 200 full step is equal to 1 revolution, then if we're only doing 1/8 of a step each time, so we need to multiply that 200 by 8, and that will give us 1600 steps that we need to do one full revolution. Okay, so now we know that 1600 steps, in our case, is equal to 80 millimeters. Now if we take that and we say 1600 is 80. Now we're going to enter X, a value X on our keypad. Well, how much steps do we need? Well, as you can see here, that's what we're doing. This is the value that we entered on the keypad. So it's Z times 1600 divided by 80. And that result will be put into this variable here. And that will be the number of steps that we need to move to actually achieve what we entered on the keypad. So I hope that's a good way of explaining it. But, you know, that's the way I did the calculation. Now, we're using a belt here. If you were using, let's say, a ball screw, then you would have a distance also that would be like a pitch. So you would enter that number and make the same calculations here. So once we have that number, then we just do stepper.run to new position. That's an Excel stepper command. And we just say, okay, go to this. And it's going to move at the maximum speed and the acceleration that we set. And then we say the current position is equal to string of Z, which is that new number that we calculated. We're doing the string thing because we want to display it on the Nokia, which we do here. So here, as you can see, we're saying current position. Because we can't display a number with that library, it needs to be a character. And then the reset numbers, that's once the move is done, it will reset all the numbers to 0, so the display is ready to enter a new number. And the draw Nokia screen we've seen, so I think that's it. Yeah, that's it. So it looks a little messy, but like I said, look at the other videos where we take each one of these modules one by one, and then when you come back to this one, then you say, oh yeah, okay, I remember we did something like this. Hopefully, you know, that will help. Like I always say, explaining code is always hard. I try to do my best, and I don't want it to take too long, so I'm actually going to shut up now, and we're going to go take a look at the result on our bench. So let's go check that out. All right, so welcome back. So we just saw the code, and I uploaded the code already to the Mega, and I powered the stepper using the external power. So we see that it's powered on. We see the light right there. And now on our little LCD, we can see the information that we put in the code right there. So you see it says enter distance, it draws an horizontal line, a vertical one, puts millimeter because that's the unit of measurement that we are using. Like I said though, you could always change that to inches in the code. Inches could be done, it's a little bit more complicated because you have fractions. It is doable, but since I'm in Canada, we use the metric system, and that's a lot easier to actually program for. So that's what we're using today, but it is doable for inches. So we have millimeter, another vertical line, and then it says current position, and nothing is there because we just started. So let's see where our motor is. So let me zoom out. And there we go. So our little belt clip is sitting right about at 0 right there. There you go. So we're sitting at 0 right now. So what I'm going to do, I'm going to try to show you guys exactly what I'm doing at the same time. Let me just pan up a little bit. Let me go this way. Alright, so let me zoom in so you can see the screen a little bit. Alright, so that should work. So I got to put my hand here without actually blocking the camera. So what I'm going to do, I'm going to enter 1, 1, 1. And as you can see on the screen, it says 1, 1, run now. So I'm going to press the delete key, which is the asterisk. So I can go back and erase those. So let's say we want to move up to, let's say, 200 millimeter, like it says here. So when I press enter, which is the number key, the motor should start moving and stop at 20 centimeters, which is 200 millimeter. So what I'm going to do now, I'm going to pan down so you can see the motor. There we go. What's that? 20. Let me zoom out just a little bit. Can you see it all more? Okay, there we go. All right. So you're not going to see it on camera, but I'm pressing the number key now to enter that number. So here we go. Pressing now. And it stopped at 20. I don't know if you saw that. It actually accelerated, then reached the maximum speed that we set in the code, and before it reached the destination, it started the deceleration. So it does both at the same time. It's accelerating and decelerating when it gets close to its destination. So now we're sitting at 20. Let's go look at the LCD again. Move up a little bit. Let me zoom in all the way on the LCD. And as you can see now, it says enter distance again. There's nothing in the box. And the current position now has been updated to 200 millimeter, which is where it's sitting now. So what I'm going to do, I'm going to enter now, I want to move to, let's say, 10 centimeters. Sorry about that. Which is 100 millimeter. So let's pan down. Let's look at our ruler again. So right now, as you can see, I'm sitting at 20. So what we're going to do, we're going to zoom out, and it should move to 10 now. So I'm going to press enter now, the number key, and there it goes. And it stops at 10. And just for fun, we're going to make it go back to 0, so I'm pressing 0, enter, and it goes to 0. So there you go. Pretty cool stuff. I mean, it's fun to actually be able to enter the distance on the keypad and then see on the LCD the current position and where it's going to go. So it gives you a visual representation and not just hard-coded in the code. So let's go back to the main camera and wrap it up. Alright, so that will do it for this tutorial today. I hope you guys enjoyed this tutorial, and if you have any questions, like I always say, post it in the YouTube comments below, and I try to respond to each one of them. Like I always say though, you know, the way I write the code, you know, my code could always be improved, could be made shorter. There's many different ways to program these things. This is just one way to get you started, and then you start experimenting with your own thing. Like I said, I'm only using 12 button on this 16. Let me switch again. I'm only using this portion, but the A, B, C, D could be programmed to do something else. Like if you're going to do inches or stuff like that, you're going to need a period. So the A could be, let's say you want to enter 0.125, you could do 0A, which is period 125. So you could experiment with that if you wanted to. Once again, guys, if you like those videos, please subscribe to our YouTube channel, and you'll get notified when we post new ones. And I also encourage you to follow us on Facebook and Twitter, and that way you'll get notified there also, because like I said before, sometimes the YouTube notifications don't work and people don't get notified. That's what I've been hearing from our users sometimes. Also, I encourage you guys to go check out our web store at Brainy-Bits.com, where we sell all the parts that we do our tutorials with. And if you can, come check us out. And if you find something and buy it from us, it helps us a lot and encourage us to continue doing these tutorials for you guys. So once again, guys, until next time, my name is Ivan, and I hope to catch you guys real soon. Take care.